Under 9 meters of Antarctic ice sits a chamber with no power source, no electricity, no machinery running to keep it cold. Just frozen ground doing a job it was never built for. Scientists carved this space by hand in one of the harshest places on Earth to hold something most people would never think to protect. When they finally opened it, something was already waiting inside. The cave sits near Concordia Station, a research base run jointly by France and Italy, deep in the interior of East Antarctica. Engineers built it by carving a corridor 30 feet deep and 115 feet long straight into the plateau. For the main storage room, workers piled excavated ice on top of a giant balloon shaped like a cylinder. Once the ice packed down and hardened around it, they let the air out of the balloon, leaving behind a hollow chamber 16 feet high and 16 feet wide. No support beams, no concrete, just ice holding its own shape, the way it has for centuries in that part of the world. The location was picked for a simple reason. Near Concordia, the ground naturally sits at about minus 61 degrees Fahrenheit, cold enough to preserve fragile ice samples for generations, without a single watt of electricity. This cave was named the Ice Memory Sanctuary, and its purpose sounds almost like something from a vault built to survive the end of the world. It was built to hold ice cores drilled from glaciers across the planet, glaciers that are melting away right now due to a warming climate. But there is more waiting just ahead. The first samples that arrived at this frozen vault came from mountains thousands of miles away, and the way they got there is a story of its own. The first samples arrived in December of 2025, close to 2 tons of ice cut from Mont Blanc in France and Grand Combin in Switzerland. That ice traveled from a port in Italy on a refrigerated ship, then by cargo plane, all the way to the middle of Antarctica, just to be locked inside a frozen room that runs on nothing but the cold ground itself. Over the next 10 years, more cores are expected to arrive from the Andes, the Pamir Mountains, and Svalbard, all threatened by rising temperatures. But storing new ice was never the most shocking part of this story. The real discovery came from ice that was already buried deep in Antarctica, long before anyone built a single wall. In a different part of East Antarctica, called the Allen Hills, a research team pulled up ice containing tiny pockets of trapped air that had not touched the outside world in roughly 6 million years. Read that number again. 6 million years. That is older than almost every fossil most people have ever seen in a museum. The team was led by scientists from the Woods Hole Oceanographic Institution and Princeton University, and their findings were published in the Proceedings of the National Academy of Sciences. This ice is now the oldest directly dated ice ever collected on Earth. Inside those frozen air bubbles is a direct, physical sample of what our atmosphere actually looked like millions of years before written history, before pyramids, before almost anything humans consider ancient. The Allen Hills region was chosen because ancient ice sits closer to the surface there than almost anywhere else on the continent. Normal ice sheets bury old ice under miles of newer snow and ice, crushing it and making it nearly impossible to reach in a clean, undisturbed state. Allen Hills works differently. Wind and unusual ice flow patterns push old, deep ice up toward the surface, meaning scientists do not need to drill nearly as far down to reach material that is millions of years old. The team behind this discovery is already planning a much longer study between 2026 and 2031, hoping to push even further back in time than 6 million years. Before we move further into this, if you're finding this interesting, take a second to subscribe. It really helps the channel grow. That number alone would have been the story of the decade. But less than a year earlier, a separate international team had already shattered a different kind of record. One focused not on the oldest single sample, but on the longest unbroken timeline of climate history ever pulled from the ice in one continuous piece. That project is called Beyond Epica, short for Beyond the European Project for Ice Coring in Antarctica. 12 scientific institutions across 10 European countries spent nearly a decade searching for the perfect drilling location before settling on a spot called Little Dome C, roughly 22 miles from Concordia Station. Conditions there are brutal. The camp sits over 10,000 feet above sea level, with average summer temperatures around -31 degrees Fahrenheit. Over 4 separate Antarctic summers, the team drilled down through the ice sheet, foot by foot, chasing a single goal, reaching bedrock. In January of 2025, they finally hit it. A 2,800-meter-long ice core, roughly 1.7 miles, pulled straight from where the Antarctic ice sheet meets solid rock. Inside that core sits a continuous, unbroken climate record stretching back at least 1.2 million years, and researchers believe it may go back even further once full analysis is complete. This shattered the previous record set by the original Epica project 20 years earlier, which had reached back around 800,000 years. In one drilling season, scientists doubled humanity's window into Earth's ancient climate. That is an enormous jump in a single measurement. But the real value of an ice core is not just its age. It is what scientists can actually pull out of it once it reaches a lab. To understand why this matters, you have to understand what ice cores actually are. As snow falls year after year in Antarctica, it slowly compacts into layers of ice, trapping tiny bubbles of the actual air that existed the moment that snow fell. Those bubbles never mix with modern air. They sit frozen in place, sealed inside solid ice for however long that ice remains undisturbed. Scientists can drill down, pull up a solid cylinder of that ice, and directly measure the exact levels of carbon dioxide, methane, and other gases that existed in the atmosphere at that precise moment in history. It is not a guess based on rocks or fossils. It is a direct physical sample of ancient air, something almost no other method on Earth can offer. The deeper you drill, the further back in time you travel, with each meter of ice at Little Dome C compressing roughly 13,000 years of history into a single slice. That kind of resolution lets scientists build an extremely detailed timeline of how Earth's temperature and greenhouse gases have risen and fallen together over more than 1 million years. And that timeline points directly at one of the biggest unsolved mysteries in climate science. Somewhere between 900,000 and 1.2 million years ago, something changed in how our planet cycles through ice ages. Before that period, Earth swung between warm and cold roughly every 41,000 years. After it, that cycle slowed dramatically, stretching out to roughly 100,000 years between major shifts. Scientists call this the mid-Pleistocene transition, and nobody fully understands why it happened. The new Beyond Epica ice core sits directly across this transition, giving researchers their first real chance to study, in fine detail, exactly what was happening in the atmosphere during the years when Earth's entire climate rhythm changed. Carlo Barbante, the professor coordinating the Beyond Epica project, described this ice core as the longest continuous record of past climate ever pulled from ice, one capable of revealing the hidden link between carbon levels and planetary temperature. Getting there took roughly 10 years of searching, planning, and drilling, along with the combined effort of scientists and support staff working through some of the harshest field conditions on the planet. Solving that mystery could reshape how scientists predict future climate shifts. But even this record-breaking core has a puzzle buried at its very bottom that nobody can yet explain. Even the very bottom of the core holds a mystery of its own. The final 210 meters, sitting right above the bedrock, are heavily deformed. The ice there appears mixed, possibly refrozen, and scientists are still not certain exactly how old it is or how it formed. Researchers hope closer analysis of this section will reveal new details about how East Antarctica's ice sheet behaved far in the past, and how ice near bedrock moves and shifts over unimaginable stretches of time. Once the main ice core was extracted, it could not simply be tossed in a cooler and shipped home. The samples were cut into meter-long sections and packed into sealed boxes, chilled to around -4 degrees Fahrenheit, then loaded onto the research vessel Laura Bassi for the long journey back to Europe. From there, teams across multiple countries began the slow, careful process of analyzing the ice, focusing first on measuring the exact carbon dioxide and methane levels trapped inside those ancient air bubbles. Ice cores are not the only thing Antarctica has been quietly protecting under its surface. A few years earlier, in 2022, a separate team of scientists used a technique called magnetotelluric imaging to scan deep beneath the Whillans ice stream in West Antarctica. What they found sitting far below the ice was an enormous body of trapped salt water, sometimes described as fossil seawater, sealed away underground for what researchers believe could be thousands of years. This discovery sat even deeper than the underground lakes and rivers that scientists already knew existed beneath the Antarctic ice sheet. The layer closest to bedrock was extremely salty, with a layer of fresher water sitting above it. That discovery mattered because it confirmed something scientists had suspected for a long time. The ground underneath Antarctica's ice is not solid rock all the way down. It is porous, filled with sediment that can hold huge amounts of water, hidden completely out of sight. Between the ancient air trapped in ice above and the ancient salt water trapped in sediment below, Antarctica has been holding on to more of Earth's history, in more forms than most people ever consider. It is a reminder that the frozen continent is not just a block of ice sitting at the bottom of the world. It is a layered archive with different secrets locked away at almost every depth. This entire effort connects directly back to that frozen sanctuary carved beneath Concordia Station. Scientists behind the Ice Memory Project believe that preserving untouched ice today gives future researchers, working with tools we cannot yet imagine, the ability to pull even more detailed answers out of the same frozen samples decades from now. Thomas Stalker, chair of the Ice Memory Foundation and a professor at the University of Bern, has said that 50 or 100 years from now, scientists will have analytical capabilities nobody today can predict. Capabilities that could reveal entirely new insights into how air and water move between oceans, atmosphere, and land. That single idea is what makes this story so much bigger than one drilling season or one research paper. Every layer of ice pulled from that cave is a direct message from a version of Earth that existed long before anyone was around to write it down. Put the pieces together and the picture is hard to ignore. A cave built with no power source, holding ice meant to outlast most of what humans have ever built. Air bubbles from 6 million years ago pulled from the ground at Allen Hills. A continuous climate record over 1.2 million years long, sitting directly across the exact point in history when Earth's ice age rhythm changed forever. A hidden pocket of ancient saltwater, sitting even deeper below the same frozen continent. None of this needed exaggeration to be extraordinary. The frozen ground beneath Antarctica has been quietly holding on to Earth's own memory the entire time, waiting for someone with the right drill, the right patience, and the right 10 years to spare, to finally open it up and read what was written inside. If you enjoyed this breakdown, make sure to subscribe, and I will see you in the next one.